Today we're going to be looking at how to generate a recursive formula that models a context. So it's probably a good idea to first look and see what a recursive sequence is. A recursive sequence is an ordered list of numbers that is defined by a starting value and a rule. So what I need to do when I'm looking at these sequences of numbers, I need to see if I can find a pattern moving from one number to the next. As I look going from 7 to 12, and then 12 to 17, and 17 to 22, I notice that I'm adding 5 each time I move from one term to the next. So my recursive routine that I'm going to write, I have to tell someone where to start because it said defined by a starting value. So start with 7. And then I have to tell them what rule to apply. Then I'm going to write this as ANS because some calculators will let you actually do some recursive work on them, and they're going to say answer plus 5, etc. So I'm going to take my previous answer and I'm going to add 5 to it to get to my next term. So that's my recursive routine for the first one. Now the second one is C. I don't know why, but I'm looking to find the pattern from 5 to 1, 1 to -3, and -3 to -7. And I'm noticing in this case I'm subtracting 4 each time, or I could also say I'm adding -4. So I'm starting with 5 in this case. Again, I always have to say where to start with. Someone should be able to read my recursive routine and recreate the sequence of numbers. There should also be 3 dots after this because this sequence should keep going. So start with 5, then ANS because we're going to take the previous answer and we're going to subtract 4 from it. You could write plus -4, but that's not simplified, so leave it as answer -4. As a quick heads up, these are not always arithmetic, which arithmetic means I'm adding the same thing each time or subtracting the same thing each time. I could have one that's 2, 4, 8, 16, etc. In this case, I would start with 2, and then I notice that I'm multiplying by 2 each time to get to the next term. So then ANS, take the previous answer and multiply it by 2. Now if the sign changed each time, so +2 to -4 to +8 to -16, I would have to be multiplying my answer by -2 to also have that sign change. So sometimes this one's called geometric because I'm multiplying or dividing by the same thing each time. Arithmetic when I'm adding or subtracting the same thing each time. There are also different kinds of sequences beyond these two, but these are the two most common that you will see. Now, in a real-life scenario of something that has a linear pattern that we can use this recursive rule to look at, this is talking about the heights above and below ground at different floor levels in a 25-story building. So we're going to write a recursive routine that provides the sequence of heights -4, 9, 22, 35, etc., all the way up to 217 and beyond, that corresponds to the building floor numbers 0, 1, 2, etc. And then we're going to use this routine to find the missing value in each table. Now the reason we start at -4, if you think about a basement, sometimes it's fully below ground. In this case, this would be a basement that's partially below ground and partially above ground. I'm looking, and it makes sense to me that if I'm moving up one floor at a time in a hotel, that I would be going up, or a building of any kind, I would be going up by the same amount each time. And I do notice from -4 to +9, and then 9 to 22, and 22 to 35, I'm going up 13 feet each time. So my recursive routine is going to say start with -4, because I always, again, have to say where I start. Then my rule is going to be take the previous answer and add 13 to it. Now, there are calculators, most scientific, but not all scientific calculators, will let you take the calculator, and in the calculator itself, you would start with -4 plus 13 equals, and it's going to say 9. Now, if your calculator will do this, you can say plus 9 equals, or sorry, plus 13, sorry about that, equals, and it'll say 22. And then if you just keep hitting equals over and over again, it'll keep adding 13 each time. If your calculator doesn't do that, you can also use an Excel spreadsheet to actually fill this in and figure out the answer during class. I also do have calculators in class that will do these recursive routines with you if yours doesn't. So to get to the fourth one, I'm going to add 13 again. 35 plus 13 is 48. And then if I do have one of the calculators that'll do this, I can keep hitting equals until I get to the 10th term. And if I do that correctly, it's going to be 126. Now, this is a little bit challenging. I want to keep counting how many terms I have until I get to an answer of 217. If I do that correctly, it's going to be this 17th term. I could also write out a table that has 25 different columns in it, or 25 rows, and I could fill each of these in as I go if I needed to. By the time I get to the 25th floor, it is 321 feet above the ground. So if your calculator doesn't do it, you actually could just fill out a little table and add the 13 each time so you could keep track of where you were until you get to the end. Now, for tonight, on your study guide, it asks you to look at a particular situation and think about how to write a recursive routine for that. So please work on that and bring it in Tuesday morning, or actually I should say the next class morning, which for us is Tuesday, and be ready to go with it. Thank you.